Okay, we're going to talk about logarithms, which are the inverse of exponents. We've been dealing with exponents, and we always want to know inverses because later we're going to want to solve for x. And we always know that when you want to solve for x, you have to do the opposite. So just what I'm talking about is, you know how if we had something like this, let's say we had this and we wanted to solve for this. Notice how this says 4 times x squared. So we would do the opposite or the inverse of multiplying by 4. So we would undo it and we would divide by 4. So that would be the opposite. So we'd get x squared equals 5. And then we want to do the opposite or the inverse of squaring it. So we would take the square root of this. And remember, when you take the square root, that would be plus or minus. So these would cancel each other out because they're inverses. So we would get x equals plus or minus the square root of 5. Okay, so it's important to be able to undo things so that you can solve for x. So that's why we have logarithms, is so we can undo exponents later. So eventually, if I would have something like this, I could solve that. Okay, I would be like, oh, how do I get the x out of the exponent? Well, hey, we're going to learn how to do that. But for now, let's just learn what logarithms are. Okay, I'm just give some basic exponents that everybody knows. Everybody knows 2 to the third is 8. If I was going to write this in logarithmic form, I would write it like this. The log, and this is my base of 2. So log base 2 of 8 equals 3. These mean the exact same thing, okay? Just like 1/2 is the same thing as 0.5. They look totally different, but they're the exact same thing. Same thing here. So when you have a log, you're going to want to make sure it equals the exponent, okay? So when you take the log of something, it will equal the exponent. So in your homework, it'll say, write this in logarithmic form. Write it as a logarithm, whatever. So I'd be log, my base is 5. So it looks like a little subscript. It's tiny and it's written right below it, okay? Log base 5 of 25. Notice this is all on the same line. The 5 is dropped below in little. Equals the exponent is 2. So if I was going to look at this, I'd be like 5 squared is 25. 2 to the third is 8. Okay, let's try another one. Write this in logarithmic form. So log, my base is 3 of 1 equals the exponent. Okay, so that's how you would write it because 3 to the 0 is 1. Right, and one more. This would be log base 10. Notice again, I'm dropping it low, of 10,000 equals 4 because it always equals the exponent. Now here's what's crazy. In your calculator, you should have this lovely button. It is built into your calculator that's always base 10. So if you ever see it written like this, it's a given that you know that's base 10. Kind of like if you see, like, you know how we have like the cube root of 8, but if you saw like the square root of 16, we don't put a little 2 there because you just know, it's the square root if you don't see a number. This is the same thing. So if you don't have a calculator yet, let me recommend, I love this one, okay, and let me turn him on here. But do you see right here, I've got the log, and we're going to be learning about this log button as well. But this is your common log. So if I just wanted to hit the log, and you can see it, of 10,000, 1, 2, 3, and I hit enter, it's going to tell me it's 4 because your calculator is built to know base 10. And later we're going to learn how to enter it in your calculator where it's not base 10, but that's just a little extra bonus. Okay, so what if you have to go the other way? And so on page 6 of your packet, there was all sorts of lovely problems right here. So for example, if I wanted to do, so you may want to go to this. It says, write these in exponential form. Let me go up here first. Write these in logarithmic form because that's what we've been practicing right here. Let's try number 14. How would you write that in logarithmic form? So you would write log, right here, base 7 of 1/7 equals -1. So it always equals the exponent. So don't make it hard, okay? I like this one, log, my base is a little b of y equals the exponent, which is an x. That's simple. Okay, now remember, you are supposed to be doing these on your own paper. I'm writing them on here so you can see them. Now, this is something we haven't really talked about yet, and we will get into it, but if the base is e, that is when you use the natural log. So you wouldn't have to write a base e because you only use him if you have a base of e. So it would be the natural log of y equals x. It still equals the exponent, but that's just a little hint. You only use him if you have base e. So that's a little hint for when you get to number 19. Okay, so same thing here. Honestly, I hate that. I would probably write this as 3 squared equals 9, but since I have it written like this, you would write log. The base is 1/3 of 9 equals -2. So you write it just like that. So easy peasy. Now, what if you have to go backwards? Notice on this, it wants you to write the equation in exponential form. This is no big deal. Look at your base, that's a 5. So it's 5 to the 4th equals 625. So you're not solving these or anything, you're just learning to rewrite this. So this is your base, so it'd be 6 squared equals 36. This one would be 3 to the x equals 5. 3 to the x equals 5. So you're just kind of practicing going back and forth. I'm looking here real quick to see if they have any with the natural log, and they don't. Look, they did base 10. And remember I said, if you don't see a base written there, you just assume it's 10. But I guess they're being nice to you for right now. But this one, you would write it 10 to the -4th. There's your base. Equals 0.0001. There you go. Looks just like that. So pretty easy, no big deal. Okay, this one says find the logarithms without the use of a calculator. No big deal. Let me just tell you the easiest way to do this is to first write it in exponential form and see what you've got. So look what I've got here. I would write this 7 to the what equals 49. And hopefully you know it's 2. 7 squared. So x is right here, it would be 2. Okay, so this would equal 2. And you don't even really have